This is Hritisha Khomane from Vidya Pratishthan's New Bal Vikas Mandir Pimpli School, studying in Standard 10th. Today, I stand before you to explain the topic Rutherford's model of atom. So far we have seen how Thomson tried to understand the atom and visualize it. He gave us the plum pudding model. But did he give an accurate picture of the atom? No, because it had so many flaws. But these flaws were taken care by Ernest Rutherford in his model of atom proposed in 1911. Rutherford's model was a result of a very famous experiment which led him to devise a significant model of the atom. Would you like to see what he did? For that, let me take you back in the time.
Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. Rutherford designed an experiment for this. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil. He selected a gold foil because he wanted as thin a layer as possible. This gold foil was about 1000 atoms thick. Shown here is the diagrammatic view of the famous gold foil experiment conducted by Ernest Rutherford. The radioactive source rich in alpha particles was kept in a thick lead block with a narrow opening. The alpha particles were confined to a narrow beam by passing them through a lead sheet with a slit. An extremely thin foil of gold was bombarded with these fast-moving alpha particles. The scattered alpha particles were detected using a rotatable detector which has a microscope and a screen coated with zinc sulfide. The whole experimental setup was placed in an evacuated chamber to prevent scattering by the air molecules. These streaking particles caused scintillations on the screen. It was expected that alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. But the alpha particle scattering experiment gave totally unexpected results. The following observations were made. Most of the fast-moving alpha particles passed straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles. Surprisingly, 1 out of every 12,000 particles appeared to rebound. Conclusion for this experiment is as follows. Most of the space inside the atom is empty because most of the alpha particles passed through the gold foil without getting deflected. Very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. A very small fraction of alpha particles were deflected by 180-degree angle, indicating that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. Now, before ending this session, I would like to thank my teachers for supporting me and giving me this golden opportunity to participate in this competition. Thank you.